Hello everyone. Today's lesson we will start double differentiation or second order derivative. You are already aware we have already completed different types of differentiation, and we are towards the last topic in differentiation. Okay, so we have already completed chain rule, logarithmic differentiation, implicit differentiation, parametric differentiation, differentiation of a function with respect to another function. So all such topics has been covered. So now finally the last topic from differentiation would be second order derivative or double differentiation. So clearly the topic states we have to differentiate twice in this following topic. Okay, so everyone knows dy by dx. What is dy by dx? dy by dx is the first order derivative. What is it, everyone? First order derivative. Now and this is the symbol for the derivative, first order derivative. Now when I say second order derivative, what do? I need to differentiate the first order derivative. So I need to do ddx of dy by dx. And what do you get? Okay, watch carefully. What do you get when you differentiate the first order derivative? You get d2y by dx square. Okay, I will write it down here. How do you read it? Read as d 2y by dx square. Remember, this is how you read it. Again, I repeat, you read it as d2y by dx square. Okay, this is how you write the second order derivative. So this is known as second order derivative, as you have obtained it by taking differentiation of the first order derivative. Correct? Also, you may write it as also it is represented by y2. Okay, we also write it as y with the subscript 2. Remember, see here, this is 2. And first order derivative is written as y1. Okay, so first order derivative y1, we haven't discussed this earlier. Now we know it is y1, and the second order derivative is y2. Correct? Also, we may write it as d2y. This is also another way of writing the second order derivative, d2 of y. Remember. Okay, so we have double differentiation where we obtain the derivative of the first order, you may say that where we differentiate the first order derivative and obtain the second order derivative. Correct? Again, I repeat, what is ddx of dy by dx, everyone? And it is d2y by dx square. Correct? Okay, what about, suppose, what if you have ddx of dy by dx whole square? Just observation. What would you do if you ever have ddx of dy by dx whole square? If you ever have this, then this follows the chain rule. Imagine the blue one is like a x. So doesn't it look like a x square? If it looks like a x square, what is ddx of x square? It's 2x. It's supposed to be like this. So what do I write here? 2 into x, that is dy by dx. This one. Okay, and a chain rule, d dx of, again, the inside one, that is dy by dx, like you do any other function in a chain rule. Okay, first we do the power and we do the inside one. Check this out. First I do the power, then the inside one. So what do you get finally? You get here 2 dy by dx into d2y by dx square. So that is the final differentiation of dy by dx whole square. So I want you to copy all of the things that I have written here. Please do copy it carefully. Whatever I have written here, this will be a part of a theory for double differentiation. Okay, so we are going to start a sum, an example based on double differentiation, where we have to differentiate a function twice. Okay, so this would be the first sum based on double differentiation. Okay, according to the sum, it says if y equals to 5 sine 4x, you need to prove double differentiation of this function is minus 16 of y. Ultimately, it will become minus 16y. So let us start, everyone. So differentiating both sides with respect to x. You know it, the first order differentiation. This will become dy by dx. There will be 5 out, ddx of sine 4x. And what is the formula? What is ddx of sine 4x, everyone? It's like ddx of sine mx. What is ddx of sine mx? If you see the standard formula, it's m cos mx, isn't it? So let's write here 5 into 4 cos 4x. Got it? Okay, so once we have this, dy by dx will ultimately become 20 cos 4x. Is that correct? Okay, then now I need to differentiate it one more time. So now differentiating again with respect to x. Why? Because it is double order differentiation. Double order means I need to differentiate it twice. Also, you know the operator here, it's d2y by dx square. So I have to differentiate it twice to obtain this. This will give me d dx of dy by dx, and that side 20 out, constant, d dx of cos 4x. Okay, remember this. So this constant will come out. No need to use product rule here. Some of you have still been using the product rule. Okay, that would not be correct. That will be a lengthy method. Okay, so now finally this gives me d2y by dx square. Everyone knows d dx of dy by dx is d2y by dx square, equals to 20 into, what is d dx of cos 4x? This is this formula, cos mx. It is minus m sin mx. Remember, this is the formula of cos mx. So that will give me minus 4 sin 4x. So ultimately when I multiply, this would give me minus 80 sin 4x. Correct? Okay, that's d2y by dx square. Let's check. Is this what I wanted? No, I wanted minus of 16y, not minus 80 sin 4x. So what will I do is, I know y equals to 5 sin 4x, and ultimately it has to be replaced by y. So I will remove y from this. I'll separate y, sorry. Okay, so from 80, if you remove 5 sin 4x, what will be the leftover? I think the leftover is 80 divided by 5 will be 16, isn't it, everyone? So minus 16 will be left over. That gives me d2 by d2y by dx square equals to minus 16. And what can I write instead of this? That would be very simply y. Okay, so finally I have d2y by dx square equals to minus 16y. You can write here, hence proved. So that's how we solve a double order differentiation sum. It is indeed a very easy sum to start with. We will solve some other sums which will be quite challenging as well. Okay, here I have the second sum based on double order derivative or the second order derivative. It says if y equals to sine inverse x whole square, prove that 1 minus x square y2 minus x y1 equals to 2. Check this out. Okay, you know y2 means d2y by dx square and y1 means dy by dx. y2 stands for double order, y1 stands for first order. Okay, so let's start. The question is very simple. So I'll write differentiating both sides with respect to x. Correct? So dy by dx equals to d dx of sine inverse x whole square. Correct? Let's follow chain rule. It will be 2 sine inverse x into again d dx of sine inverse x. That gives me 2 sine inverse x, and everyone knows what is d dx of sine inverse x, 1 by under root 1 minus x square. So to simplify this, dy by dx equals to 2 sine inverse x divided by under root 1 minus x square. Is that correct, everyone? Yes. Now from here you have two options. Okay, what you can do is, I'll show you both the options. What you can do is, from here you can follow simple normal derivative procedure and go forward. Okay, let's say differentiating again with respect to x. With respect to x, I'll show you a simple method first. Okay, what do you get? You get d dx of dy by dx here, and ultimately 2 out d dx of sine inverse x divided by under root 1 minus x square. That would be a simple method. Okay, that gives me d2y by dx square here, and here 2, and I have to follow quotient rule here, isn't it, everyone? Yes. So numerator divided by denominator, that's quotient rule. So let's open bracket, and second, that is 1 minus x square into d dx of the first one, that is sine inverse x, minus first one, that's sine inverse x, into d dx of under root 1 minus x square divided by under root 1 minus x square whole of square. The square and the square root gets cancelled, and here you have d2y by dx square equals to twice, and open bracket, what is d dx of sine inverse x? It will be 1 by under root 1 minus x square, correct, minus sine inverse x, And what is the differentiation of this? 1 by 2 under root 1 minus x square. ddx of root x is 1 by 2 root x. Moreover, chain rule, minus 2x will follow here. 2 and 2 gets cancelled, correct? Divided by here only 1 minus x square is the leftover, correct? Look at it carefully. Okay, let me zoom out a little like this. Okay, so next step would be d2y by dx square. Oh, by the way, wait, next step I will do something interesting. What can I do is, can I take this here? It will be 1 minus x square d2y by dx square. You know why I have done this? Because I ultimately want this only in the answer. In the answer it's 1 minus x square y2. That means 1 minus x square d2y by dx square minus x dy by dx equals to 2. This is what I have to prove. So I'm getting it here. So 1 minus x square d2y by dx square. And this side I get, this gets cancelled. 2 open bracket 1 plus, because minus into minus becomes plus, x sine inverse x divided by under root 1 minus x square. So that is what I have. Next step now, 1 minus x square d2y by dx square. Then let's break the bracket. 2 plus 2x sine inverse x divided by under root 1 minus x square. Okay, so we are very close to the answer. Let's check the answer. What do I have? I have 1 minus x square d2y by dx square. This I've already got it here. Check this out, I've already got it here. Then next I have x dy by dx, so I don't have that. And I have 2 as well, so I have 2 here. So from here basically I need to get x dy by dx. Let's separate the x from there. So I get 1 minus x square d2y by dx square equals to 2 plus, can I separate the x? So remove x, and then the leftover is 2 sine inverse x divided by under root 1 minus x square. I expect this to become dy by dx because I need x dy by dx. Let's see. Yes, exactly. Did you see here? This is dy by dx. dy by dx equals to 2 sine inverse x under root 1 minus x square. So replace it here. You get 1 minus x square d2y by dx square equals to 2 plus x dy by dx. So ultimately the answer would be, let me do it here, 1 minus x square d2y by dx square minus x dy by dx equals to 2. I have brought it this side, okay, on the left side. So I get 1 minus x square. Ultimately this means y2 minus x y1 equals to 2, and I suppose that's what you had to prove, isn't it? Absolutely. 1 minus x square minus x y1 equals to 2. So right here, hence proved. Got it? Okay, so I told you earlier that you could have done something else also, isn't it? So if you have understood this was very simple one by using quotient rule. Okay, so let me rub this and let me show you something different now. Okay, so let me rub this, and now I will show you a shortcut, a little shortcut technique. Okay, what I can do here is, let me rub this. Okay, so after this, now check this out. Once you have obtained dy by dx, from here you can use a shortcut technique. The shortcut technique would be something like this. What you have to do here is, now you have to do squaring both sides, here, because if you square this, you get dy by dx whole square equals to 4 sine inverse x whole square, and this will become 1 minus x square because the root and the square gets cancelled. Why I have done this? Because I know I can convert this to 1 minus x square by squaring it. Okay, that way I will get 1 minus x square dy by dx whole square like this, and that side I'll get 4. And what is sine inverse x whole square? I suppose I can replace that as well, y. That can be replaced by y, because sine inverse x whole square means what? Y. Got it? So now time to differentiate, differentiating both sides with respect to x. So a little different here. I have squared first and then only I have differentiated it. Okay, so this is a little different technique. So maybe you will find the previous one easier or this one easier, whichever you want to prefer, you can do that. So now if I have to do that, I need to apply product rule here. So second, that is dy by dx whole square into ddx of 1 minus x square. That's first, plus first 1 minus x square into d dx of dy by dx whole square, and that side 4 d dx of y, correct? So now I can do this, dy by dx whole square into minus 2x, correct everyone, because d dx of this one is minus 2x, plus 1 minus x square, check this out, and you know this, what is d dx of dy by dx whole square, we have done it earlier, 2 dy by dx into d2y by dx square, chain rule. I have to do first do the power, then do the inside one, okay, and 4 dy by dx. Okay, clearly from here I can take out dy by dx common. Can I do that? So take out dy by dx common, and I am left with minus 2x. I think not only dy by dx, sorry, but I think I can also take out 2 common, because check this out, 2 dy by dx is common, okay? So 2 dy by dx out, and I'm left with dy by dx here, one more, and then minus x. So let me write it like this. I'll write it minus x dy by dx, that is the leftover, because 2 is out, one of the dy dx is out, plus 1 minus x square, and 2 dy dx is out, so only leftover is d2y by dx square, and that side 4 dy by dx. So dy by dx, and 2 and a 2. So finally the answer, 1 minus x square d2y by dx square, I have written this first, and this here minus x dy by dx equals to 2, and ultimately replacing it, 1 minus x square y2 minus x y1 equals to 2. So that would be another way to get the answer, hence proved. I suppose we got the same answer that we've got earlier here, isn't it? So the same answer was obtained here, only the technique was a little different. Whatever you prefer, maybe you prefer the first one or the second one, both are equally correct.